Okay. You know, combinations, permutations, conditional probability, how to get the probability of A union B if there's an intersection, all that. Okay, good. I wanted to go over some stuff today. The first, yeah, it's example, 222. Hold on. Yeah, I think it's 222. It's the first one I asked you to do because it's, I think it did a pretty good job here. 222, this is the one with the, a computer store has, it's spelled out in there, has, purchases 3 computers at $500 a piece. It's on page 86. So what it comes out to is you have a store. This is example, and I want to talk about this because there's a problem. I'm not sure. Does everybody see that? Y'all did it? It's given, it's explaining it, but it's kind of an interesting way of doing it. So they're going to purchase 3 computers, and they're $500 a piece. And let's see. Then they're going to sell them for, if they can, for $1,000, right? And a piece. And let's see, they have a probability of, in whatever's left over, the computer, the firm that provided him will buy back, is it $200 or $300?
$200.
$200. So they're going to buy back what's left at $200 a piece. And so then they give you the probability of selling stuff. And I think probability of selling 0 computers is it?
0.1.
0.1, okay. And probability of 1?
0.2.
Good. Probability of 3? 0.3? And probability of selling, that's it. Well, no, probability, so this is 2.
0.2 is.
The probability of selling 3 is 0.4, right?
Yeah.
All right, so then he asks, what is the expected profit, correct, class?
Mm-hmm.
So the profit is really the total number they sell and the revenues from that minus the cost for them. So the first thing you have to realize for this problem is if he buys all 3, he's in the hole $1,500. So there's minus $1,500 for starters right there. That's how much he spent. Now, for each one he sells, he's going to make a profit of $1,000. Do y'all agree with this, class? All right, so you have X times 1,000 out here, and X is just going to be the number sold. And I think this is laid out pretty well in the book, but I want to just talk about this one because I'm going to mention a few other things. And then, since the computer store, if it's whatever he doesn't sell is left there, and it's going to be bought back, then it's going to be the amount that's going to be left over and bought back is going to be, that he'll get back is going to be plus, and it's going to be X times 2, is it bought back for $200? 200. So it's going to be X times 200 that he would get back of the things that, I better do it this way. So the amount of profit or revenue is going to be, he's in the hole $1,500. Then it's going to be whatever he sells X times 1,000. And then he's also going to get from them plus, and it's going to be 3 minus X times 200, right? 200. And that would be the amount that he gets back from that company. Do y'all follow me on this, class? I think I've made it clear. So this is his profit, and this is in the book. Do y'all see this, class? Everybody understand that? He might have a different form, but that's the essence of it, correct? All right, so if you take a look at this, the profit, and I'll just call it the profit from selling 0. Well, if it's 0, there's a 0 there and a 0 there, so it's minus 1,500. And it's going to be plus 600, right? Or he's going to be actually minus 900, isn't that right? 900 in the hole there. So profit from selling 1, and that's going to be 1,000 minus 1,500, and then it's going to be, that will be 2, so plus 400. And what is that? That's minus $100, right? The profit from selling 2 is, for 2, you got 2,000 minus 1,500 is 500, right? And it's going to be 500 plus 200, right? Or 700, and then the profit for selling all 3, means none returned, is going to be equal to $1,500. I'm just doing this, I want to do this on the board the way I do it. I'm thinking it through. Y'all with me? And he may have it set up a little different, but that's the essence of it. Now he wants the expected profit, right? Or something, he calls it the expected revenue, I think, in the book. Do y'all agree with that? And that's just straightforward. The expected value of anything, in this case, the expected value of revenue or profit, and that's this, and I think he calls it, I think he calls it revenue. The expected revenue is going to be really the summation of the probability of the sales, the number of sales, I'll call it I, times the revenue by sales. This is I equals 0 to 3. So for starters, for 0, it's 0.1% times the revenue is minus 900 plus 0. What is that? 0.2 times the revenue for 1 is minus 100 plus 0.3, and the revenue for let's see, for 2 it is 700 plus, and then 0.4 times $1,500, and that's just as straightforward as it gets for this. And I don't know what it is, but what is the expected return on investment? $700, is that right? Mm-hmm. All right, $700. You can do this. Yeah, that's right, $700. Now, is there a second part to that one or not? All right, what if I asked you, remember, that's the expected revenue, right? What would the standard deviation on that be? Or better yet, what would the second moment be on the expected revenue? Remember what standard deviation is? All right, this is the mean, isn't it? What we just got here, you could call it, I'll just call it the revenue, the mean. That bar over that means mean. You all with me, class? All right, now, if we're talking about the standard deviation, what do we have to do? For the standard deviation, well, actually, let's do the variance. The variance right here of the revenue, R, that's equal to what? That's a summation still of I equals 0 to 3 of, now you have to take the actual revenue, expected revenue, I'm calling it R of I. He doesn't do this, minus the mean, R bar, which is $700, right? Then you have to square that times the probability of each of these things. Do y'all follow me? Everybody with me on this for the standard deviation? Again, I'm just applying the formula that I gave you, and I give you some problems later on that, right? So if we were to, this is not in there, right? Yeah, all right, so what would this be? You're gonna need your calculators for this. Well, first, the probability of selling 0 is 0.1, right? Then you have to multiply it by the revenue at 0, which is minus 900. Follow me on this. It has to be minus this, the R value, which is minus 700. Y'all follow me on this? And you gotta square that value. You'll notice there's 2 negatives there, but it's squared, so it'll be positive. Everybody with me? Next one is what? Plus 0.2 times, was it minus 100? And it's plus, or minus 700 squared. Y'all follow me what I'm doing here, and it's just applying the formula. Plus 0.3, and then it's going to be 700, right? Isn't that right? 700 minus 700 squared plus 0.4, and then what is that? 1,500? 1,500 minus 700 squared, and that would be the standard deviation. Now, anybody got a calculator? Because it's fairly large for this. I can't tell you exactly what it is, but remember that's sigma squared, by the way. This is, I'm sorry, this is the variance squared. So this is sigma of the revenue squared. It's gonna be large. We're gonna take the square root in a second. Can anybody give that to me? This is one of those irritating ones. I had MathCAD open last night when I was doing all these things. 640,000, is that right? All right, 640,000. Now take the square root of that and tell me the standard deviation. This is the standard deviation. 800? If you take a look at this for a second, the standard deviation is really a measure. They say that within one standard deviation of the mean, 90% of the value, or it's a 90% chance of the likelihood of event if there's a large number of trials. Now we'll get to this later. Have you heard this kind of stuff before? And if you talk about 5 standard deviations of the mean, that means it's 99% chance of the event being in there. So for 90%, this is a large difference. The mean value, the expected value is $700 on your return. The standard deviation is 800. You could go negative real quick. Do y'all follow me? Now if that standard deviation was like $10, pretty good chance you're gonna make a profit. But if it's that big, you still have a chance of losing money in this investment, and it's a fair chance. Y'all with me? This is just kind of hand waving, but I wanted to talk about that. And then one other thing. Now, if I asked for the second moment, remember, we did variance and we did standard deviation. But remember, I talked about the expected value, and I'm going to put it in terms of x of anything, was equal to sigma of x squared plus the actual mean of x squared. Do you all remember that? How many do? Remember me doing this? All right. We have this, and we have this, right? So if we look at the expected value of the second moment of that, right? This would be the expected value of the square of the revenue. That squared, that's 640,000 plus 700 squared, which is 49,000. And that would give you the second moment squared. I'm just showing you this stuff applied to that problem. It has no real significant bearing on this problem, but you should be at least, you should have some appreciation for that. So that's that example on page 86. All right, then I wanted to do example 2.23 and talk about it. If you have questions, please ask. All right, for the second problem, for the second example, was 2.23. Tell me what that is, anyone?
Consider again the distribution of the APGAR score X.
Yeah, now this has to do with kids, and they're rated from 1 to 10 based on how healthy they are. That's all this thing is talking about. It's a prior problem. So they give you 10 values, don't they?
Although randomly select a newborn described in the mean value.
Well, give me the mean value.
Mean value of X was calculated as mu equals 7.15.
Oh, he uses mu, okay. So he uses mu. I use X bar usually. 7.5, and this is on a scale of 1 to 10, and it has to do with rating children as they're born based on how healthy they are. Yes?
7.15.
I'm sorry, 1.5. Boy. He doesn't make it easy, by the way, in the book. Go ahead.
He's calculated the standard deviation.
All right, now this is, honestly, I don't want to spend too much time on this, but I'm just trying to do more than one standard deviation. All right, standard deviation in general. All right, first we're going to get the variance of the event, and I'm going to call, what does he call it in the book, X, right? The variance of X itself is going to be really a summation for discrete values of, and here it's going to be X minus, and I'll call it X bar. He'll put mu hat there. He'll call, it's the average value. It's that squared times the probability of X, and it's just summed over all values. X equals really 0 to n minus 1, where n would be the number of values. This is 10 in this case, so it's 0 to 9. Y'all with me? I think, can you have a rating of 0 on that scale, or just 1 is the lowest? I think 1's the lowest, isn't it?
Yeah, X is 0.
It does, okay.
Yeah.
Okay, good. But this is the form. Y'all with me? Now, what we have to do for this one is we have to look at the values of X in that thing he gave you, and then multiply it by the probability, and then subtract this over. But this is just, honestly, it's just step and repeat, step and repeat, step and repeat, and add. So just to do it, for the first value of 0 minus X bar, it's just X bar, right? Or mu bar. So I'll just call it mu minus mu bar, and that's this. it's gonna be squared, and what's the probability of 0?
0.002.
All right, times 0.02 plus.
But
and it's
0.002, like 2 0.
2 zeros, all right, so it's 2 1,000s.
Yeah.
Okay, the next value, I wanna just do this though. For 1 minus that 7.15 squared, what's the probability of 1?
0.001.
Times 0.001 plus 2 minus 7.15 squared times
0.002.
0.002 plus 3 minus 7 point, boy, it's a pain, squared times, what's the probability?
0.005.
5% plus 4 minus 7.15 squared, 0.01.
2.
002 plus.
Just 0.2.
All right, I'm gonna just do it this way, plus plus. Final one is 10, right? 10 minus 7.15 squared, what's the probability of 10?
0.1.
0.0,
1.
10%? Now, you do this, you're gonna get a value, that's the variance. What's the variance? Can you tell me what that is? It's given. By the way, on MathCAD, it's much easier to do this. I wanna ask this question before I continue. How many know what MathCAD is? All right, the reason I'm telling you this, MathCAD is what you see is what you get. You change one thing, everything changes in there. And the reason I like it, with MATLAB, you have to rerun, basically it's not what you see is what you get, it's cryptic and stuff like this. MathCAD is so much simpler. For these problems, it makes it a breeze. It's trivial to do them. And maybe I'll show you this in a bit. Anyway, what is this value?
1.5815.
This is the variance, not the standard deviation?
Yeah,
1.15?
1.5815.
1.5?
815.
All right. Therefore, if that's the variance, the standard deviation is just the square root of that. And that is
1.26.
1.2.
just something to show you. These are discrete, not continuous time. I had these down in my notes to do simply because they kind of drive home the point how straightforward this stuff is. There's nothing really tricky, but you have to get the probability right and you have to do the squaring operation right. And it can never be negative for variance. It can be for mean value. That was example. Then on problem 2.29, I'll give you a page on this. I assigned that one, didn't I, class?
Yeah.
Okay. On 2.29, and this is so straightforward. It says the probability mass function, which is the same thing as probability density function of a memory, is given as this. Compute the expected value. Does everybody have your books here? You don't have the book? Have you tried to get the book or not? Okay, you need access to this book for a lot of stuff, so make sure you get it, because I know it's closed book, closed notes, but I'm gonna reference a lot of material. Yes, sir?
So the examples in the old book are the exact same as the one in that book.
The what book?
Like every example you call is the exact same on like the PDF book.
Oh, your book, okay. All right, yeah, he kindly provided us a PDF that's on Google, is it on Google something, Docs or Google Scholar? Google Scholar, okay. I gotta be real careful about this. Now, the book that's listed for the course right now is a different book. But the reason I'm using this book is this is the book that Adel Bashir gave me that he used on the spring, apparently. So if I don't get in trouble with the editor, I'm not gonna force you to buy that other book and use it, all right? Now, I'll use problems out of this one. Yes, sir?
Are you talking about the book you showed last time?
Yeah.
Yeah, that one was like 170, and that digitally is like 56.
Well, it's also free, isn't it?
The first version, which is the same.
Okay.
Mhm.
If I don't get in trouble, I'm not gonna cause a fuss.
Oh, it is annoying to get that one.
Huh?
Like, they won't like stay open whenever you.
I will say one thing though, just for everybody's sake. The book I used when I sat where you were, it was a senior level course when I took it. I used Larson and Schubert. I still have it. I have all sorts of notes in there. Everything, I learned a lot in that course, and it's more applied to electrical and computer engineering. A lot of the complicated distribution functions, Poisson, all that stuff, and things that are a little more complicated. I have highlighted and I have all sorts of notes. I still reference that to this day. I'm gonna say, I would suggest, at least because this is an engineering text, buy your engineering text. You won't lose these usually. You'll lose your notes. And then write in them and save them because you'll reference this stuff. I know online, there's so much information out there and you find yourself going for it and looking. Oftentimes you're overwhelmed by the amount of information, but you all know your circuits, right? Did you use Irwin's circuits book, right? All right, do you still have it?
We only use the online version.
Use this iPhone.
You gotta be kidding.
Oh, yeah, design.
Yeah. I mean, I just
You
realized.
can get older
this.
versions online.
I mean, things like that you use daily, or that you'll reference frequently, I always keep in my office. I mean, I don't keep my health book or anything like that, but all the stuff that I had when I was in college that was something directly related to engineering, even chemistry. I thought I was done with chemistry. I had to take crystal chemistry. All that stuff was so important to a lot of the work I did later and with plasma physics and stuff like this. You'll be surprised how much of that over the course of your career you're gonna reference, unless you're in sales. That's different. But I mean, if you're doing real engineering work, you're always referencing stuff.
This could be in sales, probability.
Kind of, yeah, but believe me, we're gonna get into problems where it has to do with the expected outcome for things like identifying a target. I'm radar, so you're gonna get that, I guarantee you. All right, so this is problem on page 91. I wanna do a couple of these. I have just a gut feel that there's people probably have, if I put this up there, something that they don't quite understand or don't see. To me, it's very obvious, but I don't know. So for this problem, and I'm gonna ask you some other things that are a little more complicated. They give you X and then probability of X. And so for X equals 1, it's 0.05. For 2, it's 0.1. For 3, oh, no 3, 4 is 0.35. For 8, it's 0.4, and for 16, it's 0.1. So that's the event, and that's the probability. Then he asks, what did he ask for in this one?
Expected value of X.
All right, expected value of that X, or really, he'll have capital X. So that's straightforward. It's the likelihood times the probability of, the value of X times the probability of X. So this is gonna be, first one is just 0.05 plus second one is 0.2 plus third one is 4 times 0.35, what is that, 1.4? Right? Plus 8 times, and that's what, 3.2? I'm just taking 8 times 0.4. Y'all with me, class? And what's the last one? 1.6. And that's all there is to it. What is that value gonna be?
6.45.
And that would be the mean or expected value. Usually I do this. That's how it usually is. He'll do this. He'll use U. And that's just his business. Everybody gets to use a symbol they like. So that's expected value. What else? He asked for the variance?
Yeah.
All right. Now, you can get the variance two ways. First, you can get the second moment, and then you can subtract off the square of that value from the second moment to get the variance, or you can do a direct subtraction. Either one's fine. I'm gonna do it this way. I'm gonna calculate the expected value of X squared first. And again, it's the same exact thing we just did, but instead of X, now we put X squared. Correct? Everybody with me? Just work with me on this one. Let me do it this way. So for this one, so we have 1 squared is 1. So it's the first part is 0.05. Now we square this, we get 4. 4 times 0.1 is 0.4, right? Plus, sorry. Oh, I thought, then we're gonna square this, that's 16, right? 16 times 0.35, what is that? So if we have, this is 1.4 times 1.414. trying to do this in my head. I'll just put it this way, 16 times 0.35, stay there with me, and plus, then you have 8 squared, 64, right? Times 0.4 plus, and finally 16 squared times 0.1, what do you get for all that?
57.25.
57.25? All right. Now, we can get the variance of x, which is a lot of times just put down as sigma x squared, because that's the standard deviation squared. That's the way it's usually written in a lot of books and online, and actually in journal papers. So that's going to be equal to the expected value of x squared minus the mean value of squared, and that's going to be 57.25 minus the mean value, which is 6.45 squared. Can you tell me what that is?
15.6, right?
0.65? All right, take the square root of that to get sigma x, the standard deviation. 60, so it's about just under 4, isn't it? 3.6? 3 point what?
3.996.
96 approximately, okay. So that would be that. What else does he ask for in that?
Standard deviation.
We just got that. That is the standard
Yeah,
deviation.
just compute variance, again, use that shortcut.
We just used a shortcut. All right. That is anything else?
Nothing.
Y'all with me? Just an application of this. So for 30, this may seem boring, but it's kind of necessary. I'm going to jump to the next stuff in a second, but I just want to get through this. I don't think there's really many subtleties here, but I'm going to do problem 30 that's in the book. And then I'm going to jump to continuous random variables, and we'll get to some things how if you have an equation like y equals ax squared plus b, and you know the statistics, the standard deviation and the variance and all that, in x, how do you get it for y from that? It's interesting. That gets a little more complicated. But anyway, for this one, problem 2.30, this is the problem. This is another one of those where he gives you, I think, y and p of y, is that right? All right, so go ahead. For y, value of
0.
probability,
0.6.
go ahead.
1. 0.25.
2,
0.1. 0.05.
that's 3, 4.
There's no 4.
There is, okay. Okay. And what do they ask? Expected value?
Yeah.
All right, just by looking, what's the expected value of y? All right, 0 times 0.6 is 0. 1 times 0.25 is 0.25 plus 0.2 plus y, 0.15. So what is that going to be?
0.6.
0.6 is the expected value. Does the expected value of y squared, is that it, or what? What's the next part? I think he asked you if you get $100 back for y squared, something like this. Read that, if you don't mind.
Suppose an individual with Y violations, is that what you're talking about?
Yeah, so y is the number of speeding violations, is that right?
Yeah.
Sorry about that, it really doesn't matter what it represents, but you just have to know how to do this. But so you have, go ahead.
So suppose an individual with Y violations incurs a surcharge of 100 Y squared dollars.
$100 times the y squared, not y. All right, so now it's saying that he has to pay 100 y squared. So what you have to do is find the expected value of y squared. You all follow me on this? Okay. What is the expected value of y squared? We could do it with the standard deviation formula, right, if we wanted to, but how would you get it? The expected value of y squared is just going to be, this is the function, right? You take the functional form, and you step it through all possible values, 0, 1, 2, 3s, and you're gonna square this. The function is squaring that value, and you multiply it by the actual value, the percentage, the chance of that occurring. Y'all with me? That's all this is. So this is gonna be, well, you got 0 squared is 0, so that's it. Then 1 squared is 1, so you have 0.25 plus. Then you have 2 squared is 4, so that's 0.4 plus. Then you have 3 squared is 9 times 0.05 is 0.45, correct? And what is that gonna be? So, that's 0.7 and 4, 1.1, is that right? All right, so that's y's expected value of y squared, and that means the actual expected amount of money would be 100 times that, or $110, and I think he has that too in the answer. Does he ask another part of that or no?
No, that's it.
That's it, good. All right. Now, moving on. Put it left right here. Okay, I'm gonna put this down. I'm gonna apply a lot of this in the next class, which is Wednesday, because we have Monday off. It's Memorial Day. This stuff's kind of boring. It's necessary to go through it, I guess, until you are bored. So now, if you have a functional form, like, for instance, y is equal to ax, let me capitalize that, plus b. Here, a and b are random constants. X is a random variable, which makes y a random variable. Y'all follow me on this? And take a look at this. The variance of this, variance of y, is usually given as sigma squared of, and then it will have ax plus b down here, or it'll be y. Y'all follow me? I'm just trying to show you this is an equation. X is a random variable, y is a random variable, a and b are just constants. So there is a standard deviation with x, and there's going to be a standard deviation with y, or this. Y'all follow me? They're different, generally. When you get this standard deviation will just be a squared times the standard deviation of x squared. Now the reason for that is the constant b will have nothing to do with it. I'm going to try to explain this as easy as I can. And we'll spend more time on this later, but if you take a look at this, if we take a look at the standard deviation, or how about we talk about variance first? Variance of y. Well, that's really the variance of ax random variable plus b. Variance, if we're talking about a summation, in here it's going to be the functional form, which will be ax bar plus b minus the average value of this, which will be ax bar, or I'm trying to show you that this is the mean value of that, plus b, and it's going to be all that squared times the probability of each value of x. And here x will be equal to 0, whatever the values are, to n minus 1. Now, I'm going to just say this. If you take a look at this before you do anything right here, y'all follow me? I just put the value of the function in here, right? This is the mean value, which would be ax bar plus b, because a and b are constants. This is the function. Take a look at this for 1 second. The summation is there, but what happens in here? I have a, and then it's going to be quantity x, that's the random variable, minus x bar, plus b, but it's minus b, that cancels, and I have this squared times the probability of x. Now if you look at this, and I'm going to omit the summations, take a look at this for a second. What do you actually get? Well, I'm going to have a squared, that can come out in front, that's a constant, times the summation of x, the random variable, minus x bar squared, times the probability of x, right here. And it would be really from x over all possible values, say, well, this right here is by definition the variance of x. Right there. Y'all see that? The a and b don't matter. The a squared matters because it's weighing the x, but b doesn't matter. It's a constant. It doesn't affect the variance. Y'all with me? Now, when you take a look at the standard deviation, though, remember that's the variance, right? So the standard deviation, when we look at the mean value, I better do it this way. The mean value of y, what is it going to be? Well, it's going to be a times the mean value of x plus b. Y'all follow me? Because a and b are just constants. With me, class? We could go through the math on that, but that's what it's going to be. The a and b really don't affect it other than it skews the value by a times it, and b is a constant, just add it on. Now, if that's the value, and you take a look at what the expected value of this is, of y squared, pardon me, of the second moment, right? That's going to be sigma of y squared, the variance of that plus y bar squared. Y'all follow me? The only thing I've done is I've got the variance of y over there. Y'all see that? It's a squared times variance of x plus the average value of y squared. That's that, right? Right here. So what is this going to be? Well, this is a squared times sigma x squared from there, plus the average value squared. Here's the average value, so I have to take ax bar, average value at plus b squared, and that would be the expected value of y squared. Now you can see one thing that happens here. You see how this formula right here, and I put it's just a linear formula. I have to take the mean value of this, which is there, right? And I have to square it. So that's where it gets a little more complicated. You can see here the expected value of y squared isn't just a squared times the expected value of x squared plus b squared. There's this term. There's going to be 3 terms in there when you square it out. Y'all with me, class? When you do problems, you'll see the impact of this and how it works. All right, I needed to talk about that. I'm going to talk about the binomial distribution just briefly because it's going to be used so often. How many have heard of the binomial distribution? I put it down before. I'm going to just say that this is something where there's 2 outcomes, either success or failure, and you want to know in N trials how many successes you have. And let me just show you this. I've mentioned it before, but I have to do this because the problems that we're going to be doing use this, and they use Poissons a lot to get things into discrete time. We're going to do something in continuous time real quickly too. So if we talk about the binomial distribution, it's really talking about if you want to choose, and I'll call it just the probability of k successes and n attempts. Here n is going to be greater than or equal to k. K is going to be the number of successes, and n is the number of trials. And then we have P is going to be the probability of success. And what this is going to be n factorial over, this looks a lot like combinations, over n minus k factorial times k factorial. Then it's going to be times the probability of success times k, the number of trials, times 1 minus the probability of success, which is the probability of failure, times n minus k. So that's the formula. It's in your book. Just write it down, binomial distribution. Let's apply it to some things you understand very well. We're going to flip a coin 3 times, assume it's an even coin. How many times, or take 3 coins that are all the same, same likelihood of probability or heads, and flip them at once. Probability of getting 0 heads. Follow me on this, class? So I want the probability of getting 0 heads in 3 tries, coin tosses. Here, n is going to be 3, k is 0. So this is 3 factorial over n, which is 3 minus 0 over 3 factorial, times 0 factorial. What's 0 factorial, class? 1. Right, times the probability of success. In this case, it's just going to be 1/2, right? If we're tossing a coin, it's a fair coin. It's that it's going to be to the k power, which is 0, times the probability of 1/2 times n minus k, which is 3. Take one look at that. 3 factorials cancel, you get 1/2 cubed, which is 1/8. Does everybody agree that that would be the likelihood of getting 3 heads or 3 tails in a fair coin flip? All right, now what's the probability of getting 1 head, we're going to call it head, in 3 tries? 3 factorial, right? Then it's 3 minus 1, or 2 factorial, times 1 factorial, which is 1, times the probability of his success, which is going to be 1/2 to the 1 power, times the probability of a failure, which is 1/2 to the 3 minus 1, or 2 power. And that is, if you look at this for a second, it's really 3 times 1/2 cubed, or 3/8. Does everybody follow me on that? I'm just trying to make a point about this, and you'll see what. All right, what about the next one? What's the probability of 2 of 3? 2 heads and 3 attempts. How many you want to bet it's the same thing as 1 head and 3 attempts, which is the same thing as 2 tails and 3 attempts, right? Y'all follow me? Because the probability is the same. It's 1/2 for each. So this is going to be what? Still 3 factorial, that's n factorial. Now I'm going to have 1 factorial here, and then, or maybe I should, I'm just going to call it 1 factorial here, and this is going to be 2 factorial here, and then it's going to be 1/2, in this case, squared times 1/2 to the first power, and this is going to be 3/8 as well. Agreed? Finally, what's the probability of all 3 of them being heads? Probability of 3 equals 3 factorial, right, over 0 factorial, and here it's going to be 3 factorial times, in this case, it's going to be 1/2 to the 3rd power times 1/2 to the 0 power, and this, in fact, is going to be what? 1/8. Now, add them all up. What do you get? 1/8 and 1/8. 3/8 and 3/8, it's 8/8 is 1. It always works that way. Y'all with me? So this is the binomial applied to the easiest problem I could think of, coin tosses. Usually, when you're dealing with the binomial distribution, you're dealing with a large number of events, but there can only be 2 outcomes. Either it happens or it doesn't. Y'all hear me? Binomial distribution is not like Poisson and the other ones where there's an infinite possibility of outcomes. Here, there's only a success or a failure. Where I use this in radar, and it is used, is when we're talking about either a target is there or it's not. And if a target is there, then you go through a different flow chart to find out and basically discriminate what kind of target, all that other stuff. And if it isn't there, then you move on. But the decision is key. So statistically speaking, however you design the parameters to make that decision, you have to be very precise for like a 99.999% confidence interval that we'll get into. I know you're anxious for your quiz. Before I give you a quiz, I wanted to do one more problem. I was just going to do something with binomial, but I think I'll tell you what. I'll postpone this next part until Wednesday. Can you all make sure? I try never to give you homework over a break or a holiday. I'm going to ask you just do a little reading and 1 or 2 problems that are very obvious, but it applies to continuous random variables. So in some of this stuff, so I can at least move on in class without a lot of people having to be brought back into reality. All right. I'm going to just mention one thing, and I'm going to put it on the board for your quiz, because I told you you're going to get what combinations are and what permutations are. Now, you have to know the difference, but we talk about permutation of n, k. That is really equal to n factorial over n minus k factorial. Does everybody follow me? I'm just putting it up there, right? Now, if we talk about combinations of n combination k, that's equal to n factorial over n minus k factorial times k factorial. Y'all with me? Think wine, think beer. Don't think too much. I try to get everybody every other row. Would you two guys right here, man, jump on top of this row? No, you stay, you guys stay. You two, can you move there and you move in the back? All right, so sorry guys, you gotta vacate, move over to the next row, all right? And then somehow we're gonna find room for you guys. You guys can, some of you move over here. I try to get it every other row simply to minimize the likelihood of cheating so I don't have any problems. And I probably should have stuck you at the wall, but do me one favor, it's closed book, closed notes. When you receive this, would you please? What? You just sit there. I'm trying to get, yeah. Please put your name on this.